Question 12. Do friends Andy and Bob participate in a game of bowling every week? From past experiences, it is known that both friends' scores are approximately normally distributed, where Andy has a mean of 150 with a standard deviation of 30, and Bob has a mean of 165 with a standard deviation of 15. Assuming that their scores are independent, which of the following values is closest to the probability that Andy will have a greater score than Bob in a single game? This was one of our questions from unit or review number 1. So I want you to think, if you want to look back to this is review 1. I think it was number 7. This is applicable here. All right, pause the video, see if you can try it on your own, look it up, and then I'll go over it. All right, I'm going to go over it. I'll have my solutions ready. Here we go. So in this question, it says, what is the probability that Andy will have a greater score than Bob in a single game? So we're combining both their efforts into one game. And so what we're doing is we're taking Andy's and Bob's distributions. They're both normal. And since we know they're both normal, we want to find the probability that Andy scores greater than Bob. So we want to subtract those distributions. So if I do Andy minus Bob, we want to find the probability that that number is going to be greater than 0. So I want to find that distribution for Andy minus Bob. First, with normal distributions, when we're trying to find the mean and standard deviation, the mean is simply the difference between their means. So Andy has a mean of 150, Bob has a mean of 165. When you subtract those, you get negative 15. That is the mean. With their standard deviations, again, just like when you're combining two standard deviations, we want to square their standard deviations, add them together, then take the square root, like the Pythagorean theorem. So they have 30, 15, and their combined standard deviations will actually be bigger because when you add them together, you get a larger value. So that standard deviation is 33.54. So now we can answer the question. We want to know what is the probability that when Andy and Bob play together, that Andy's going to score greater than Bob, meaning that their difference of scores is going to be greater than 0. This is a normal CDF question. Second vars, 2. Your lower bound will be 0. Your upper will be infinity, 1e99. Don't mess around with 1,000. Just put 1e99, 1 second comma 99. That's the highest possible number. Your mean value is negative 15. And your standard deviation is 33.54. I'll work it out, hit paste, and you get about 0.3273, about 33%. So in one game, the probability that Andy will have a greater score than Bob in a single game is approximately 33%. Psst. I know it doesn't give you this formula directly on the formula sheet, but I want you to look on this part of the formula sheet. Imagine if you didn't remember what to do with those standard deviations. But look at down here. If you go to that sampling distribution part and you see the difference in the means is just the difference in their population means. Well, in that previous problem where it was just one game, right? So imagine that's being 1. There's your formula right there. Square root of your standard deviations squared with an addition plus them. So that minus will go to squared. You can see it in there indirectly. So I wanted you to be able to look out for it, okay? All right, next question.